So we're going to look at solving quadratics by graphing and square roots. So what we're going to use is the idea of a zero function. This is where y equals 0. Or in other words, if we have a graph, this would be where the graph, and in some cases a parabola, crosses the y-axis. So these would be our solutions. So here we have a graph of y equals x squared minus 1. So where the graph crosses this y, or the x-axis, would be our solution. So we would say that x equals -1 and x equals +1. These would be our two solutions. And of course the coordinates would be -1, 0 and 1, 0. So graphing is actually the quickest way to find our solutions, because if I were to substitute a -1 for x, so y equals, if I do -1 squared, this would be 1 minus 1, which is 0, where y is 0. If I also did the same thing here, where I have 1 squared, so 1 minus 1 is 0, so y would equal 0. Now in this case, we would only have one solution. And we know there's only one solution because the vertex or the graph only crosses the x-axis in one spot. And in this case, it happens to be the origin. There can be solutions that touch only here or here. It's just coincidence that this one happens to be the origin. Now in this case, we have no solution, because the graph does not cross the x-axis anywhere. So this would be no solution, which is definitely possible. All right, so here we're going to graph this on Desmos. When it says f of x, you can simply just graph y. I can't get to the sides here. Let me shift this over. Make it smaller. Here we go. Let's try that again. Equals x squared minus 18x plus 5. So of course this one is kind of off the graph, so we're going to have to zoom out a little bit and try to get it to fit the window. I'm going to use it says round to the nearest hundredth. So the first point would be 17.72 and then 0. While the other one, it looks like, of course, it's not going to be always pretty perfect whole numbers. This one would be 0.280. So sometimes you're going to have to, use the Desmos and estimate here. Now, we're going to go ahead and solve using square roots. Remember that if you have 2 squared, I'm not going to use 2. We'll do 3 squared. That gives you a value of 9. If you have -3 squared, that is also 9. So when we talk about square roots, we have positive and negative values. So let's look at this one. We have 3x squared minus 75 equals 0. I'm going to add that 75. So basically I'm solving for x here. So we have 3x squared equals 75 divided by 3. So x squared equals 25. Now, in order to solve this, we still have to take the square root. So the x equals, now, 25 is a perfect square, but going back to this idea here, it would be a positive 5 and a negative 5. Sorry, I don't know why I put 1. So this would have two solutions, x equals positive 5 and x equals negative 5. And again, if you were to graph it on Desmos, you should see that as well. I'm going to save us that time. I feel like you guys can graph on Desmos. Let's look at another one. So this case, I have the square root of 49. In this case, negative 49 does not, even though 49 is a perfect square, -7 times -7 is positive 49. 7 times 7 is positive 49. There's no way to get a negative 49 with the square root. So in this case, we would have no solution. So that graph would not cross the x-axis. Here, let's go ahead and solve this. I'm going to add 18. So we have c squared equals 27. Now 27 is not a perfect square, but we can definitely stretch it out to factor out a perfect square. I believe 3 times 3 times 3 will get us what we need. So I can circle this. So 3 times the square root of 3. And we're talking about positive and negative values here because we are taking the square root. So the way we could write that without having to write it twice is just put the positive negative sign right there. It has a name, but I can't recall at the moment. So this comes out. So see how the skill is coming back to us. Not very common, but it does happen. So let's go ahead and solve this guy here. So I'm going to add 35 on both sides. So s squared equals 0. Guys, it's not possible. So this, in this case, this would also be a no solution.